Hello and welcome to a math studies video. I'm going to explain what derivatives are, how we use them. Now, we don't need to have a very strict understanding of derivatives in math studies, but we do need to have a bit of a clue. So first, let's remember some basics. Remember the equation of the line. So you remember that they had this form. So we represent it in two axes. For example, this one would look like this. And I could say that this is a function. Or this one would look like this, and I can say that this is a function, and so on. Do you remember this clearly? Well, we use lines, and this is how we measure slope in mathematics, how steep things are. So it's the number that multiplies the x in the equation. You look at these lines here, these are their equations, and I can say, well, here are the slopes. And just to make it clear exactly how do I calculate this slope, here's the line, I'm just zooming into one. Suppose I'm riding a bike from left to right always, and I can see I'm going up, so the slope is positive. And how do I measure it? Well, I see how, the slope is going to be 2, and the way I see it is it's just going to be a ratio of how much do I increase on the y-axis for how much do I increase on the x-axis. So for each unit I move to the right, I move 2 units up, hence 2 units divided by 1 unit gives me that the slope is 2. And that's how we calculate slope in maths. How we determine how steep things are. Very, very important, because that's all that a derivative is about. So the rough way to calculate slope will be, well, suppose that I'm in a mountain. Okay, I'm on my bike on a mountain and I'm going up the hill. I can draw this line and realize, hold on a minute, if I put like a little grid in front of it and realize, yeah, for each square that I move to the right, I move 2 up, hence the slope is 2. Great, now I have my method to calculate the slope. And I can do the same thing if I have a function rather than a mountain. This would be the function of sine x, which you don't have to learn, but just as a clue. Sine of 2x, I think, actually. So, so again, I can draw my line. I can see my bike if I want to again and say, well, there's my grid. Perfectly. F of x is equal to sine of 2x. Fantastic. Now, drawing the line is good because you understand and you can see how things are working out. But the cool thing about mathematics is that we end up having perfectly accurate methods. So drawing a line is not very accurate. There's an exact way to calculate the slope of the function at a point. You can realize that here, the slope here is going to be 0. The slope here is going to be negative because I'm going downhill. Here's going to be 0 again because I'm flat. The bike, if you put the bike here, it's not going anywhere. But at each point, if I just draw the line, it's not going to be very accurate. So I have an exact way to calculate the slope. And that's what the derivative is. It's just an exact way to calculate the slope at a given point of a function. So let me give you a clear example, which is just going to be a small invitation, and we'll have the exact method in a different presentation. So here I have in black f of x equals x squared represented. Here you go. And I have some lines at different points. So A, B, C, at those points I've drawn a line. And I want to know the slope of f of x equals x squared, of the function in black of the parabola, at A, at B, and at C. So I draw the lines. And I can see that at B, well, it's going to be 1 to the right, 4 up. So at B, the slope of f of x equals x squared is going to be 4. At A, it's going to be 2. And at C, is going to be minus 2. So when we make the derivative of a function, we call it f prime of x, and this is what it's going to look like. Of x squared, f prime of x is going to be 2x. And this function will give me the slope of f of x at each value of x. Let me repeat that. F prime of x, for each value of x that I put here, is going to give me the slope of f of x. F prime of x gives me the slope of f of x. I put the value of x here, and it's going to give me the slope. So for example, f prime of 1 is going to give me 2. And yes, I saw that the slope is 2. F prime of 2 is going to give me 4. Hey, that works. I put the x2, which is where the b is, and it gives me that the slope is 4. F prime of minus 1, I go to minus 1, which is where the c is, and it gives me this minus 2. So you see how this function allows me to calculate the slope of the original function for each point of x. So that's really what the derivative is. It's a function to calculate the slope of a function. So important thing to mention, the way we write it and how we talk about it. Firstly, you may hear derivatives and differentiation and they are the same thing. Normally we'll say derivative as a noun, like I'm making the derivative, and differentiate as a verb. I'm going to differentiate. And finally, there are different notations for derivatives. Now, things like this, things that don't look very friendly sometimes. Now, are these the same thing? And the answer is yes. Not exactly, perhaps, but for the scope of this course, they're definitely exactly the same thing. So, for example, if you have this, I can say f prime of x equals to x, and if I have y equals x squared, I can say that y prime is equal to 2x, or that dy dx is equal to 2x. So again, what are we doing here? Let me just give you a quick understanding of why this is so. A function represents anything that changes in time, right? Remember how in our models we put, like in the x-axis, we put the time. So I can have like money changing in time, or all sorts of things changing in time. So what the derivative is going to be telling me is the rate, the slope, right? And the slope is how much the y-axis changes for each change on the x-axis. It's called the rate of change. So if you think about it, let's go back to something that you understood a long time ago, something like dividing. And you know that dividing is like, hey, I have 3 apples divided between 3 people, and each person gets 1. It's just split up proportionally. Well, the derivative in one sentence, what the derivative is, understanding how to calculate how much something changes in time. And that's all it really is. And that's important because we live in a changing world. Thank you for watching. Goodbye.